Hi everybody, welcome to the Unit 6.1 review video. Let's go ahead and get started. On the first problem, they're wanting us to graph and fill in all critical parts for each hyperbola. Well, if you notice in problem 1, our hyperbola equations are normally set equal to 1. So that's the first thing I'm going to do. And in order to get this set equal to 1, I have to divide everything by 144. And when I do that, 9 over 144 reduces down to 1 over 16. So this equation is going to become x plus 2 squared over 16. And then 16 divided by 144 becomes 1 over 9. So it's going to be y minus 1 squared left on the top over 9. And it's going to equal 1. So there's my new equation in the appropriate form that we like it to be in. And I'm going to tell you that this is horizontal because the x squared term comes first at the top. Now, my center is at -2, +1. Because remember, our x value, it's x minus h and y minus k. So this became a positive, so the x value has to be -2 and the y value has to be +1. Now the 16 is my a squared and the 9 is my b squared. So a is going to be 4 and b is going to be 3. Now the length of my transverse axis is always 2 times a. So that'd be 2 times 4, which is 8. And in order to find c, c squared equals a squared plus b squared. So c squared equals 16 plus 9. So c squared equals 25, which means that c is equal to 5. Now, I have to find my vertices, and the way I'm going to do that is I'm going to actually graph. So let's go ahead and zoom out a little bit so we can see. Okay, so my center is at -2, 1. And then it says, remember this is a horizontal ellipse, so my a value means I'm going to go left and right 4. So I'm going to go 1, 2, 3, 4 to the right and 4 to the left. And those are my vertices because a represents the distance from your center to your vertices. So my first vertex is at 2, 1, and my other vertex is at -6, 1. Now my C value is, or B value, sorry, is the distance from my center to my co-vertices, which go in the opposite direction of my vertices. So I'm going to go up 3 and down 3. Oop, I went up 4 on accident. So my co-vertices, which it actually doesn't ask us for, are at -2, 4 and at -2, -2. C is the distance from my vertices to my foci, and that's 5. So I'm going to go 1, 2, 3, 4, 5 to the right and 1, 2, 3, 4, 5 to the left because my foci are always on the same line as my vertices. Now I'm going to take my co-vertices and vertices and make a rectangle out of them. And then I use that rectangle to draw my asymptotes, and I start by drawing them through the corners and through the center of my rectangle. And they ask me for the slopes of those asymptotes. Well, slope is rise over run, so I start at my center because that's a point on one of my asymptotes, and from my center I rise 1, 2, 3, and then I run 1, 2, 3, 4. So if slope is rise over run, the slope of my asymptote is 3 over 4. Now that's one line. The other asymptote is decreasing to the right, so that's going to be -3 over 4. And the coordinates of my foci, this is my foci here on the outside, is 3, 1. That's the first foci. And the second foci is at 1, 2, 3, 4, 5, 6, 7, -7, 1. And then my E value is always C over A, so it's 5 over 4, which comes out to be 1.25. Now I'm going to go ahead and draw my hyperbola. And I draw it through my asymptotes and through my vertices approaching the asymptotes. And there's my hyperbola. Okay, now trying the next one. This one is already in the form that we like it to be in. The y term, comes first, so we know it's vertical. The center is at -1, because that's the value with my x, and +3. The 4 is my a squared, so a is 2, and 36 is b squared, so b is 6. The length of my transverse axis is always 2 times a, so that's 4. I go ahead and plot my center at -1, 3. And then I know that it's vertical, so I'm going to plot my vertices above and below my center. And I'm going to go up 2 and down 2, because that's my a value. And a represents the distance from my center to my vertices. My b value represents the distance from my center to my covertices. So I'm going to go right 6 and left 6. And I can go ahead and draw my rectangle that connects my vertices and my covertices now. And my vertices lie at -1, 1 and -1, 1, 2, 3, 4, 5. My c value is equal to c squared equals a squared plus b squared. So c squared equals 4 plus 36. So c squared equals 40. So c is the square root of 40, which is approximately 6.32. So I'm going to start at my center, and I'm going to go up 6.32 and down 6.32, because my foci always lie on the same line as my vertices. So when I go up 6.32, my first foci lies at -1, 9.32. And then I'm going to go down from my center 6.32. And my second foci lies on the coordinate -1, -3.32. Now, my asymptotes are the lines that go through the corner of my rectangle and the center of my rectangle. And the slope of this asymptote is rise over run. So I start at my center, I rise 2, and then I ran 1, 2, 3, 4, 5, 6. So it's going to be 2 over 6, which really reduces down to 1 over 3. And one is increasing to the right, so it has a positive slope, and one is decreasing to the right, so the other one has a negative slope. So one is positive 1 over 3, and the other asymptote has a slope of -1 over 3. My E value is always C over A, so it's going to be the square root of 40 over 2. And when you enter that in your calculator, you get 3.16. Then I go ahead and draw my curve in. It's going to go through my vertices and approach my asymptotes. And there's my hyperbola. Okay, moving on. Now they're wanting us to write the equations for the hyperbolas using the given information. So let's go ahead and start, because it gives us in this problem number 3 the vertices. So at -2, 0, and at -2, -6. And then the foci are at -2, 2, and -2, -8. Well, my center of my hyperbola is going to lie right in between my vertices and my foci. So I know my center. I need to find my center. I need to find my A value. B value, and whether it's horizontal or vertical. Those are the 4 pieces of information that I need to know. Well, my center is at -2, -3. My A value is the distance from my center to my vertices, which is 3. And since my vertices are on top of one another, I know this is vertical. And to find my B value, I have to use the equation C squared equals A squared plus B squared. So C squared equals 3 squared, which is 9, plus B squared. And we know C is the distance from my center to my foci, and that's 5, so C squared is 25. Now I have to find 9 plus something equals 25, so B squared has to equal 16. So B is equal to 4. And my since it's vertical, my y term is going to come first, so it's y minus the y value of my center, so y minus -3 turns into y plus 3 squared. And then A squared always comes first on the bottom, so that's 9. And then it's minus my x term, x minus my x value of my center, so x minus -2 turns into a positive 2 squared, and then b over b squared, which is 16, and then it's always set equal to 1. So there's my equation. And if I actually wanted to finish this out, I could draw my vertices or covertices to the left and the right 4. Draw my rectangle through my vertices and my covertices. Draw my asymptotes. And then go ahead and draw my hyperbola through my vertices and approaching my asymptotes. Okay, moving on to problem 4. Now, on this one, they give us our foci at -3, 5. And at 5, 5. So I know my center lies directly in between my foci. So my center is going to be at 1, 5. And that tells me, remember, I need my center, I need my A value, B value, and whether it's horizontal or vertical. Well, since my foci are left and right, I know my vertices have to be left and right of my center. And the way I find those is my transverse axis is 6. Well, my transverse axis is always 2 times the A value. So if the transverse axis is 6, my A value has to be 3. And the A value is the distance from my center to my vertices. So I'm going to go left and right 3 from my center. And my center, I already said, was at +1, 5. And since my vertices are left and right, we know it's horizontal. And now I have to find my B value. Well, remember, C squared equals A squared plus B squared. C is the distance from my center to my foci, which is 5. Oh, I'm sorry, 4. 1, 2, 3, 4. So C squared is 16. A squared is 9 plus B squared. So B squared has to equal 7. So B is the square root of 7. Now, I know that this is horizontal, so my x term comes first on the top. So it's x minus 1 squared over A squared, which is 9, minus y minus 5 squared over B squared, which is 7, equals 1. So the square root of 7 is approximately 2.65. So I know I can go up and down from my center 2.65 to get my covertices. And then I can draw my rectangle between those two. Draw my asymptotes. And then I can go ahead and draw the hyperbola through the vertices approaching the asymptotes. Alright, so let's move on to parabolas now. Oh, we got one more. Sorry. Still on hyperbolas. So we're going to plot my vertices at 2, 7, and 6, 7. And I know that my center is going to be halfway between those, so my center is going to be at 4, 7. My A value is the distance from my center to my vertices, so that's 2. My B value we need to find, and we need to figure out if it's horizontal or vertical. Well, my vertices are left and right, so it's horizontal. And then we use C squared equals A squared plus B squared to find B, but in this case we only know A squared is 4, and we don't know C and we don't know B yet. So what I have to do is my slope of my asymptotes are 5 over 2, so I know I'm going to rise from my center 5 and then run 2. So my co-vertices have to be 5 above and 5 below my center. So I know my B value is going to be 25. So C squared has to equal 29 and B has to equal 5. So now I have enough information. I have all 4 pieces that I need to write my equation. It's horizontal, so my x term comes first. So it's x minus 4 squared over a squared, which is 4, minus my y term, so y minus 7 squared over 25 equals 1. So there's my equation. Now if I wanted to finish drawing, the square root of 29 is 5.38. So C has to equal about 5.39. And I can go 5 to the left of my center, 5.39 to the right and to the left. And then I can go ahead and draw my asymptotes. And then my hyperbola. Okay, so now we're going to move on to parabolas. They ask us to graph and fill in all critical parts of the following parabolas. The vertex in this case is going to be at -1, +3. My focal width is the absolute value of 4p. Well, this is 4p, -12 is, so the absolute value of -12 is 12. Now to find p, I divide -12 by 4, and that's -3. And since x squared comes first, I know it's going to be vertical. And since my p value is negative, it's going to open down. So I'm going to go ahead and plot -1, 3 as my vertex. And then I know my focus has to be 3 below my vertex. So my focus is going to end up at -1, 0. Now my directrix has to be 3 above since my focus was 3 below. So that's my directrix. And then my axis passes through the focus and the vertex. So the equation of my directrix, it crosses the y-axis at 6. So the equation of my directrix is y equals 6. Now my axis crosses the x-axis at -1, so the equation is x equals -1. My focal width is 12, so I go to my focus and I put 2 points on either side that are 12 apart. So I'm going to go 6 to the right and 6 to the left. And then I connect my vertex with those 2 points to the left and right of my focus. And there's my parabola, opening down and being vertical. Okay, on number 7, same thing. This time my vertex is at +4, -3, since 4 is with my x value and 3 is with my y value. My focal width is the absolute value of 4p. Well, 8 is 4p, and the absolute value of 8 is 8. To find p, I divide 8 by 4 and I get positive 2. And since y comes first, this time it's going to be horizontal. And since my p-value is positive, it's going to open up to the right. So I plot my vertex at 4, negative 3. My p-value is 2, so I'm going to go 2 to the right. It's positive 2, so 2 to the right. And since my p-value is 2 to the right, my directrix is going to be 2 to the left. The axis is the line that passes through my vertex and my focus. So my focus is at 6, negative 3. The equation of my axis, it crosses the y-axis at negative 3, so it's y equals negative 3. And my directrix crosses the x-axis at 2, so the equation is x equals 2. My focal width is 8, so I'm going to put 2 points on either side of my focus, 8 apart. So I'm going to go 4 up and 4 down. Then I'm going to connect my vertex and my focus with my parabola opening up to the right. Okay, moving on to writing the equations for the following parabolas using the given information. Well, they tell me my vertex is at 2, 8, so I'm going to plot that point. Oh, wait, 2, 7. I thought I did. My directrix is at y equals 4. That means I'm going to have a line that only crosses the y-axis at 4. So I know my focus. If my directrix is 4 below, my focus has to be 4 above. So my focus is going to be at 2, 12. And to write the equation of a parabola, you need to know the vertex, which they give us in this problem as 2, 8. You need to know the p-value. And when you know the p-value, you can find out what 4p is. And then you need to know if it's horizontal or vertical. So we know the vertex. And we know that since our focus is 4 above our vertex, we know that it's going to be vertical. And since it's 4 above, our p-value is positive 4. So 4p has to be 16. So that gives me enough information because I know that since it's vertical, the x term is going to come first. So it's x minus 2 squared equals 4p, which is 16, times y minus 8. And there's my equation. Now I can finish out drawing my parabola because I know my focal width is the absolute value of 4p, which is the absolute value of 16. So I go 8 to the right and 8 to the left. And then I can draw it, connecting those 2 points. Okay, let's move on. We have another one where they give us the vertex at 1, negative 2. And the focus at negative 1, negative 2. So remember, I need my vertex, I need the p-value, I need 4p, and I need to know whether it's horizontal or vertical. Well, they give us the vertex at 1, negative 2. My focus is 3 to the left, so I know that it's going to be, oh, I'm sorry. It should only be 2 to the left. So my p-value is negative 2, which means 4p is negative 8. And since my focus is to the left, I know this is horizontal. So my equation can already be written just given that information. So since it's horizontal, the y term comes first. So it's y plus 2 squared. Or sorry, the y term is squared. Equals 4p, which is negative 8, times x minus 1. Okay, I can go ahead and finish drawing this because I know my focus is to the left. So my directrix has to be 2 to the right. That's my directrix. My axis is the line that goes through those 2 points. That's my axis. And my 4p is negative 8, and my focal width is the absolute value of that, so it's 8. So go to my focus and make 2 points on either side to where they're 8 apart. So I count 4 above and 4 below my focus. Connect those 3 points, and I have a parabola that my equation represents. Okay, last parabola equation problem. My focus is at 1 up 3. My directrix is at x equals -3. That means it crosses the x-axis at -3. So it's a vertical line. Now my vertex has to go in between my directrix and my focus. So my vertex is going to be at -1, 2. Remember, that's one of our pieces of information we need to know. The p-value, since my focus is 2 to the right of my vertex, the p-value is +2, which means 4p is +8. And this is going to be horizontal because my vertex and focus are to the left and right of each other. So since it's horizontal, the y squared is going to be term, or square. The y term is going to be squared, so it's y minus 2 squared equals +8 times x plus 1. Okay, so I can go ahead and finish this out. Since 4p is 8, the absolute value of 8 is 8. So my 2 points on either side of my focus are going to be 8 apart. So I count up 4 and down 4 from my focus. And then I connect those points. And there's my parabola. Alright, we're moving on to the multiple choice questions. Well, in number 11, it says, in the diagram below, the plane y is perpendicular, that's the key word, to the axis of the cone z. So if this plane came and sliced through this cone, it would make, if you looked at the top, it would make a circle. So anytime it's perpendicular, a plane is perpendicular to the axis, it's going to give you a circle when it cuts through it. Okay, on number 13, it says identify the conic section that the equation represents. Well, the things that I'm interested in are the coefficient in front of the x squared and the y squared. And in this case, it's +2 and +2. Well, 2 equals 2. So if the coefficients are the same, it's a circle. So A is the answer to number 13. Sorry, A was the answer to number 11 also. Okay, so now I'm moving on to number 14. And it says, in the diagram below, the plane J is neither parallel nor perpendicular to the cone K. Well, I'm going to extend this axis. And since I know it's neither parallel or perpendicular, that means it's not a circle or not a hyperbola. Because if it's perpendicular, it'd be a circle, and if it was parallel, it'd be a hyperbola. So the only things left are ellipse and parabola. Well, when I extended this middle dotted line from the plane, it cut through both sides of the cone. And if it cuts through both sides of the cone, I know it's an ellipse. So B is the answer to number 14. And I realize I skipped number 12, so let's identify the conic section about the equation below. Well, once again, I'm looking at the coefficients of in front of x squared and y squared. And in this case, it's 2 and -3. Well, 2 does not equal -3, and 2 times -3 is less than 0. And because the signs don't match, which means they multiply to a negative number, it's going to be a hyperbola. So B is the answer to number 12. If they're two different numbers and they have different signs, it's a hyperbola. Alright, number 15. It says identify the conic section that the equation below has. Well, once again, I look at the coefficients in front of x squared and y squared. Well, in this case, it's only y squared. Well, if you only have one squared term, it's a parabola. You know what? I messed up. If it's parallel, it's going to give you a hyperbola. I was right. No, sorry. If it's parallel or perpendicular, it gives you parabola. And then if it's neither of those things, it's either an ellipse or a parabola. So I said it right the first time. I apologize. So D is the answer to 15. Let's go on to last problem, 16. It says identify the conic section the equation represents. Well, let's look again at the coefficients in front of x squared and y squared. Well, they're not equal to each other. 4 does not equal 8. And since they have the same sign, that means when you multiply them together, it'd be greater than 0. So 4 times 8, it would give you a positive number. Their signs match, so it's an ellipse. So C is the answer to number 16. Okay, y'all, that's it. I tried to go fast so it wouldn't be long, but I'm pretty sure it's going to be long anyways. I hope that y'all come in and ask us any questions you have in the morning at 6:45. And good luck on y'all's test tomorrow.